A brush fire is growing in the Everglades.
With thousands of acres already scorched, firefighters are battling to get things there under control.
Most people think the Everglades is just a swamp full of alligators. But look closer. There is a war happening in the tall grass. For decades, we have been losing ground to an invader that treats this ecosystem like an endless meal. These muscular, silent predators have been devouring birds, mammals, and deer while dismantling the food sources that panthers, alligators, and native wildlife depend on to survive. We thought we understood the scale of the problem. We thought our estimates were close. We were wrong. It took a massive, raging fire to expose the real truth. When the grass burned away, it did not just reveal snakes. It revealed a landscape that has been fundamentally altered by a monster we created. And the numbers coming out of that ash are terrifying. The scorched earth revelation. The air in the Everglades does not just feel hot. It feels heavy. It presses against your skin like a damp cloth. But on a particular morning in December 2025, the heat is coming from something other than the sun. A crew from the Florida Forest Service is moving along the edge of a sawgrass prairie. They are carrying drip torches, metal canisters with a loop at the end that drip a mixture of diesel and gasoline. They are not fighting a fire. They are starting one. Within minutes, the peaceful marsh transforms. A line of fire, bright orange and furious, begins to consume the dry vegetation. The sound is like 1,000 sheets of paper crumpling simultaneously, a crackle that overwhelms the buzzing insects. Smoke climbs upward and turns the Florida sky into a hazy gray ceiling. To an outsider watching from a distance, this looks like destruction. It looks like something going terribly wrong. Here is the thing. This is actually medicine. For thousands of years, this land burned naturally. Lightning would strike the ground and the fire would clear the old dead vegetation, recycle nutrients back into the soil, and prevent the trees from swallowing up the grassy rivers. The Everglades was built to burn. But lately, these controlled fires have taken on a new and darker purpose. They have become a weapon in a war against something that cannot be found any other way. As the firewall advances, pushed by a steady wind, the ground ahead of it comes alive. You see the usual suspects first. Grasshoppers leap in every direction. Birds swoop low to catch fleeing insects. The few marsh rabbits that remain scramble for cover. But then comes the movement that sends a chill up your spine, regardless of how many times you have witnessed it. A slow, heavy displacement of grass. Something large is pushing through the vegetation like a machine parting water. A Burmese python, easily 10 feet long, is forced out of the hiding place it has used for months. For the first time, it cannot rely on its camouflage. That intricate pattern on its scales, the one that makes it disappear into shadows on the water, is completely useless against a backdrop of charred black earth and orange flame. The snake is exposed. In April 2025, during a controlled burn in Palm Beach County, land managers witnessed this unfold in real time. They watched as the fire stripped away the cover and the ground beneath it appeared to move, covered in snakes emerging from what had seemed like empty marsh. It was a moment that confirmed the worst fears of everyone watching. The infestation was not just bad. It was everywhere. You have to understand the scale. We are talking about thousands of acres where the grass can grow tall enough to hide a school bus without a trace. Finding a snake that does not want to be found in terrain like that is not difficult. It is impossible. But fire changes the physics of the hunt entirely. Reports from the field are striking. In one instance, a hunter watched smoke clear to reveal a 12-footer trying to reach a canal. In another, the heat flushed out a nesting female that had been invisible for months, exposing a clutch of eggs that would have produced 50 new predators by summer. This is what fire does. It converts the python's greatest advantage, the ability to vanish, into its greatest liability. They have to move, and the moment they move, they can finally be seen. But the fire reveals something beyond the snakes. When the grass burns away, what remains is a marsh that is eerily, disturbingly empty of everything else. Raccoons gone, foxes absent, opossums vanished. The fire exposes the pythons, but it also exposes the crime scene beneath them. A landscape where the only living thing left in large numbers is the predator that ate everything else. The silent invasion. To understand why we are burning the swamp, you have to understand how we lost it. It did not happen overnight. It was a slow disaster that began with ordinary decisions and ended with an ecological catastrophe most people still do not fully grasp. It started with the pet trade. In the 1980s and 90s, Miami was the center of exotic animal imports. People wanted something unusual, something that signaled a certain kind of boldness. They bought baby Burmese pythons. At 20 inches long, they are manageable. They curl around your arm. They fit in a tank in your living room. But pythons do not stop growing. That manageable baby becomes a 6-foot snake within a year. Then 8 feet. Then 10. Then you have a predator the size of a telephone pole in a glass enclosure, eating rabbits, watching your cat with an unsettling level of focus, and costing more to feed than you anticipated. So people did what overwhelmed people do. They drove to the edge of the swamp, opened the container, and let the animal go. They thought they were giving it a chance at freedom. They were releasing a biological weapon into the most vulnerable ecosystem in North America. Then came Hurricane Andrew in 1992. The storm hit South Florida with catastrophic force. Breeding facilities, pet shops, and private collections were destroyed. Untold numbers of pythons were scattered into the wild simultaneously. The Everglades received them without resistance. It was warm, wet, and stocked with prey. The pythons had no natural predators. Nothing in Florida's evolutionary history prepared any species to handle a 20-foot constrictor. Alligators fight back, yes, but a full-grown python can consume an alligator. We have the photographs. The pythons had the numbers, and they had the time. And for years, nobody noticed. That is the part that does not get enough attention. The invasion was silent. Pythons are ambush predators. They do not pursue prey across open ground. They submerge in the water and hold their breath for 30 minutes at a time. They dissolve into root systems and mud banks. They are biological ghosts. By the time authorities understood the scale of the problem, the pythons had already won the first phase of the war. The statistics read like numbers from a different planet. In core python zones of the Everglades, marsh rabbit populations have dropped by 99%. Raccoons down 99%. Opossums down 99%. Bobcat numbers in free fall. 20 years ago, driving through the Everglades at night meant constant animal sightings, eyes reflecting in headlights, rustling in the roadside brush. Now, in the worst affected zones, it is silent. Wind and mosquitoes. Nothing else. The python is not just a predator. It is a food web destabilizer. It eats the prey that native carnivores depend on. The Florida panther, already critically endangered, finds depleted hunting grounds because the pythons reached the deer first. The domino effect runs through every level of the ecosystem, and the breeding capacity of these animals accelerates the collapse. A single female lays up to 100 eggs per year. Even with significant juvenile mortality, the math produces an exponential curve. Current models estimate anywhere from tens of thousands to over 100,000 pythons in the wild. But that figure is a guess, because for every python anyone sees, there are estimated to be 100 more that nobody will ever locate. They have claimed the sawgrass. They are expanding into the mangroves. They have been documented swimming between islands in the Florida Keys. They are adaptable, resilient, and permanently hungry. This is why the burns exist. You cannot fight an enemy you cannot see. The pythons had a 30-year head start. They dug in, multiplied, and restructured the ecosystem around their presence. The only way to close that gap is to change the terms of engagement. Strip away their advantage. Remove the cover. Make the ghost visible. The firestorm strategy. Burning a swamp is not as straightforward as it sounds. You cannot walk into the marsh with a lighter and hope something productive results. Prescribed burning is a science with high stakes and narrow margins. The Florida Forest Service and the National Park Service plan these operations months in advance. The timing window is specific. Too dry and the fire burns too hot. It can scorch the soil itself, destroy mature trees that are designed to survive a surface fire, and jump containment lines toward residential areas. Too wet, and the fire cannot carry, leaving a patchy, ineffective result. The teams search for a precise combination: the right humidity levels, wind direction that keeps smoke away from highways and hospitals, and the dry season window between December and May, when water levels are low and the grass is primed to ignite. The primary goal is reducing fuel load. That is the accumulated dead grass, dried leaves, and fallen debris that builds over time. If it is not burned intentionally, a lightning strike eventually produces an uncontrolled burn fueled by a decade of built-up material. Prescribed burns are a safety measure even for the human communities that border this land. But in the python hotspots, the Francis S. Taylor Wildlife Management Area, Big Cypress National Preserve, the strategy takes on an additional dimension. Here, the fire is about exposure. Crews work in coordinated teams using ATV, swamp buggies, and helicopters equipped for aerial ignition. The helicopter approach is something to witness. Flying low over the marsh, the aircraft drops small plastic spheres filled with reactive chemicals. The moment they contact the ground, they ignite. Thousands of acres can be lit in a single afternoon. The fire moves through the sawgrass, a plant with edges sharp enough to cut skin that burns with startling speed. It consumes the thatch layer beneath, the dense mat of dead organic material near the soil surface. This thatch is the python's infrastructure. It is where they regulate temperature. It is where they wait in ambush. When it burns, the insulation vanishes. The ground becomes hot and exposed. The humidity drops. Direct sunlight hits scorched black earth that absorbs heat without shade to moderate it. Pythons are ectotherms. They rely entirely on their environment to manage their body temperature. What a burn creates is conditions they actively want to avoid. They move. They seek out unburned tree islands or the depth of the canals. This is the flush, and the hunters are waiting for it. After a burn, the South Florida Water Management District's python elimination contractors move in. The ash has not fully cooled. The smoke still drifts in low ribbons across the ground. And on that black surface, a tan and brown python stands out the way a lit match stands out in a dark room. A U.S. Geological Survey study using radiotelemetry confirmed what hunters already knew from experience. After a fire, tracked pythons moved nearly 50% more than their baseline. They were searching, exposed, and making decisions under pressure. In April 2025, following the Palm Beach County burn, python sightings spiked by 15% within 48 hours of the fire's completion. That is not a marginal improvement. That is a different category of hunting. One video circulated widely that spring. A hunter moving through still smoking ground in a freshly burned section of the Everglades. He stopped and pointed at a limestone rock. Curled against it was a massive snake, with nowhere to go. The animal struck when approached, a sound like pressurized air releasing, jaws open, rows of backward curving teeth catching the light. But without the wall of grass to disappear into, the hunter had the angle. Two people wrestled it into a containment bag. The snake was full of eggs. One capture. One generation removed in 5 minutes. The cleared ground also enables technology that the dense grass previously made useless. Drones with high-resolution cameras can operate effectively over burn zones, spotting animals sunning on exposed ground from 300 feet above. Environmental DNA sampling from water sources tells scientists where pythons are present. The burn provides the visual confirmation needed to act on that intelligence. Hunters in the black. The hunters who work the post-burn landscape are not casual. They are state contractors, men and women hired specifically to remove invasive constrictors. They spend nights wading through alligator territory, enduring mosquito pressure that requires genuine tolerance, and wrestling animals with bare hands in terrain that actively fights back. Uneven limestone bedrock hidden under ash and mud. Holes in the rock that turn an ankle without warning. The constant awareness that a 12-foot snake that has just been forced from its home is not in a cooperative mood. They walk the ash line, the boundary between burned and unburned ground. Pythons congregate there. They want the security of the remaining cover while remaining close enough to the open ground that they can move quickly if needed. It is a predictable behavior, and it is one of the few genuine advantages the hunters hold. Even with all of it, the fire, the exposure, the technology, the telemetry data, they are still hard to find. They bury into mud. They slide into the water-filled solution holes in the bedrock. The fire creates a window of opportunity measured in days before the new grass begins to emerge. In Florida, vegetation does not wait. Green shoots appear within 48 hours of a burn. The hunters know this. They move fast, work the ash while it is still visible, and take everything they can find before the cover returns. The fire does something else beyond the python equation. It clears invasive plant species, melaleuca trees that drain the water table, dense stands of Brazilian pepper that displace native vegetation. It restores the natural flow of the landscape and encourages the return of native grasses. And here is where the strategy reveals its uncomfortable complexity. Fresh green grass draws rabbits. Rabbits draw rats. Rats and rabbits draw pythons. The burn that exposes the current generation of snakes also creates the conditions that attract the next generation. It is a cycle of disruption and return. But the key difference is that when the new growth is short and the ground is clear, the hunters are positioned and watching. The python comes back to a trap. Ghost in the grass. We burn the grass. We scorch the earth until it looks like a different world. We catch the snakes and count them and call it progress. And in the moments after a successful day, with the numbers tallied and the containers loaded, it feels like we are pushing the line back. But in the humid silence of the swamp at night, when the fire has died and the smoke has thinned and the black water reflects the stars, a specific question hangs in the air. Are we winning? Or are we making them stronger? The Everglades covers 1.5 million acres. The burns touch a fraction of that. The patrols cover a fraction of the burns. For every python dragged out of the ash, fighting and hissing, how many are sliding silently into the deep mangrove zones where the airboats cannot navigate and the fire cannot reach? Here is the theory that genuinely keeps biologists awake. We are not eliminating the pythons, we are selectively breeding them. Evolution typically requires thousands of years to produce meaningful change. But in the glades, we may have hit the acceleration button. By consistently hunting the snakes that are visible, the ones that bask on levee banks, the ones that hold still in predictable patterns, we are systematically removing the less cautious individuals from the breeding population. What remains is the inverse, the hiders, the animals with instinctive aversion to human activity, to engine vibration, to the scent of people moving through the grass. Hunters are already reporting behavioral shifts, snakes moving only during the pitch dark of new moon nights when human vision is at its most limited, animals adjusting their circadian patterns in ways that suggest something more than random chance. There are accounts of pythons burrowing deeper into the limestone bedrock during cold snaps, surviving freeze events that should have been fatal. The fire theory is the most unsettling. If we turn large sections of the Everglades black through repeated burns, will camouflage follow? Will we inadvertently select for melanistic individuals, darker snakes target that disappear for collapse from the inside? The concept involves genetically modifying animals to pass a population-limiting trait through every generation. Release enough carriers, let biology do the work, and the population crashes. It sounds like a precise solution. But the failure scenarios are the kind that keep geneticists up at night. What if the modification mutates unpredictably? Life does not follow the code we write for it. Could we produce a sterile population that does not reproduce, but also does not die? Animals that live for 40 years consuming prey with no biological pressure to stop? Could the gene transfer horizontally across species boundaries in the microbial environment of a subtropical wetland? A mechanism designed to eliminate Burmese pythons jumping to the native indigo snake, the eastern diamondback, the ecosystem's own reptiles, triggering the extinction cascade we were trying to prevent. Pheromone traps are another active research area. Scientists are working to synthesize the chemical signature of a female python in reproductive condition, an olfactory signal powerful enough to draw males out of unreachable habitat. But the concern is concentration. If these chemical lures work too well, they may function as aggregation signals rather than targeted traps, pulling snakes in from large surrounding areas and increasing density in managed zones rather than reducing it. You could theoretically draw animals out of unreachable deep mangrove territory into areas where hunters are waiting, which sounds like progress until the containment fails. You have just gathered the population you were trying to thin and moved it somewhere you cannot fully control. Drones with thermal cameras, scent-trained detection dogs, bounty structures designed to incentivize removal at scale, Judas snake programs that use the animal's own biology against it. All of it is active. All of it produces results. None of it is operating at the speed the crisis demands. The python does not pause while we develop better tools. It lays eggs while we write grant proposals. It expands its range while we run controlled trials. And it adapts to every pressure point we introduce, sometimes within a single generation. But right now, fire is the only tool that delivers results at landscape scale. Not targeted removal, not surveillance technology. Fire. It resets the visible